data to use for the angled projectile lab. So angled projectile are ones that are shot upward at some type of an angle and then hit their peak and eventually fall back down. So they go up and down. We are going to play with two different toys that we can make work as an angled projectile. I'm going to show you the two toys, and then I'm going to put the data up on the board. I collected it earlier out in the hallway. Now I'm just going to show you what the two stations look like. Station number one is the Nerf disc launcher. So it is this guy right here. It has a little disc inside of it, and it's battery powered. What we're going to do is we're going to put it on the ground at an angle, any angle that you like, because you're going to actually calculate what the angle is. And then we are going to let the disc go. It is going to go up as an angle projectile and then fall back to the ground. I am having the students measure two things: the total distance that it travels in the X direction and the total time that it's in the air. So this is what it looks like. And then it falls to the ground. We run out of space in the classroom, but I have some data for you guys to use here in just a second. The other toy is a stomp rocket. This guy is going to be kind of the same idea. It's going to go on the ground, but for this one, instead of having to measure the total distance, the only thing that they have to measure is the total time. So we are going to put it on the ground at an angle like this, and then they're going to step on it, and it goes up and back down. In this case, it hit the ceiling. Out in the comments, it does not do that. And they are going to measure the total time that it takes that it's in the air. Knowing those numbers, I'm going to bring you to the board right here. All right, so I moved my camera. We are now going back to see the actual data that you're going to use. So station one, the disc that went in the air, it went like a horizontal projectile. Out in the hallway, I measured the total distance to be 5.85 meters. That's delta X, the total distance all the way over here. And the total time that it took for it to land was 1.74 seconds. That means the time at the top, halfway there, you just divide it by 2, and you end up with 0.87. Okay, so we have the total horizontal distance, the total time, and then I cut that time in half, and we have a time at the top as well. Your goal is to find the actual velocity. In order to find the actual velocity, when something takes off, the actual velocity is a mix of the VIY, the velocity it needs to get off the ground, and the VX, the velocity it needs to push horizontally. Okay, those two combine to form the hypotenuse, which is the actual velocity that the disc leaves with. Okay, you can set that up at the moment of impact, or the moment that it leaves. You can turn it into a triangle and solve for each of them mathematically. In order to find velocity, we need to know VIY and we need to know VX. We're going to have to use equations in order to do that. So I've got the steps for you to follow over here in black. First thing you're going to do, you're going to solve for VX. The equation for VX is just delta X over delta T. That's the really easy one because you have both of those numbers. The harder one to solve for is VIY. The reason that it's harder is people forget about this equation right here that works at the top. You can plug in gravity, solve for VIY if you remember to use the time at the top. This equation only works at the top where the time is 0.87 because that is the only place where VFY is equal to 0, and we can get rid of that number. Once you have Vx and VIY, you can use the Pythagorean theorem to solve for the actual velocity, which is this right here. It's also on your equation sheet. And finally, to find any angle, you could use sine, cosine, or tangent. I always use tangent just because you have VIY over Vx first. So tangent of the angle we're looking for is always opposite over adjacent. So in order to do this, you would divide those two. You do have to use your second function in order to get the tangent. For station number 2, the stomp rocket, all you had to do was measure the full time. 1.14. You will also need the time at the halfway point, the time at the top. So if you cut that in half, you have that number there as well. For this, your end goal is to solve for delta y. Along the way, you'll have to solve for VIY first because that's part of the equation. You will need to use this equation again to solve for VIY, and you have to remember it only works at the top, so you have to use the time at the top, not the time all the way over. That's also the time that you're going to want to get delta y, because that is the height, and that occurs at the top. At the peak is where you have your maximum height, and that's what you're solving for. Send me text if you have any questions. Those are the 2 lab stations that go with this assignment. Thank you.